The Pythagorean theorem tells us that if we have a right triangle, let me draw this right triangle, that the sum of the squares of the shorter sides of the two legs, so let's say that the length here is a, the length there is b, that the sum of their squares, a squared plus b squared, is equal to the square of the length of the hypotenuse. So if the length of the hypotenuse is c, this is equal to c squared. What I want to do in this video is really just apply the Pythagorean theorem to figure out the sides or the missing sides of different right triangles. So in each of these three examples, these are clearly right triangles, and they've given us two of the sides, and we're going to use the Pythagorean theorem to figure out the third side. So right over here, let's see, we have a right triangle. They give us two sides, length 4 and 5. And you might be tempted to say 4 squared plus 5 squared is going to be equal to c squared. But you need to realize that the 4 is one of the legs. The 4 is one of the legs, but the 5 is the hypotenuse. It is the side opposite the 90-degree side. So 5 in this example is actually c. So if we call this 4, maybe we could call this b or a. We actually get 4 squared plus b squared is equal to the hypotenuse squared is equal to 5 squared. So you get 4 squared plus b squared is equal to 5 squared. And I really want to emphasize that. We knew that the c was 5, or that 5 is c is the hypotenuse because it's the side opposite the right angle. And so we're actually solving for one of the legs here. So you get 16 plus b squared is equal to 25. If you subtract 16 from both sides, you get b squared is equal to 9. And then b, if you take the principal root of both sides, you get b is equal to 3. We obviously don't care about the negative root because we're talking about distances or measurements. So b is going to be equal to 3 in this example right over here. Now let's do this one. Once again, clearly a right angle. They give us two sides, and these two sides are the legs. The one that we're trying to solve for is actually the hypotenuse. The hypotenuse is not given. Remember, the hypotenuse is the side opposite the right angle. That's the one that's not given. So this time we actually will be solving for c. So we could call this c right there. That's the length of the hypotenuse. So we're going to get 9 squared plus 7 squared is equal to c squared. 9 squared is 81. Plus 7 squared is 49. That's going to equal c squared. 81 plus 9 gives us 90. Plus 40 is 130. So we have 130 is equal to c squared. And so c is going to be equal to the principal root of 130. And we can see if we can simplify that a little bit more. I'm going to do a prime factorization of 130 to see if we have any perfect squares inside of it. So 130 is the same thing as 2 times 65, which is the same thing as 5 times 13. And so it actually does not have any perfect squares in it. You can't simplify it anymore. So we just say c is the square root of 130. And then finally, we have this one over here. Once again, clearly right triangle. They've given two sides. And we have to make sure that we're solving for the right thing. So the two sides have given us. One of them is the hypotenuse. It is the side opposite the right angle. So they've given us the hypotenuse. They've given us the c in this example right over here. That's 4 square roots of 2. So this is one of the legs. And then we're going to have to solve for the other leg. And that's going to be equal to this leg squared plus this leg squared is going to be equal to the hypotenuse squared. So we could say, let's just call this a. We could call it a or b or x or whatever we want to call it. But we can write a squared plus 4 squared is equal to 4 square roots of 2 squared. And so you have a squared plus 16 is equal to 4 squared is 16 times 2, right? Square root of 2 squared is 2. 16 times 2, which is equal to 32. And then we can subtract 16 from both sides. So if we just let me just rewrite this. A squared plus 16 is equal to 32. Subtract 16 from both sides. You get a squared is equal to 16. Take the principal root of both sides. You get a is equal to 4. So this is an interesting one right over here. This is actually a right isosceles triangle. This length is 4. This length is 4 right over there. But it's also a right triangle. So this is, if you have an isosceles right triangle like this, if the two legs are 4, the hypotenuse is 4 times the square root of 2.